Right. This problem is called sum of three values. So we're given some array, and we want to find three values at different positions that sum up to some target x. And the array is of length 5,000. So we can afford like an n squared kind of solution. Of course, the naive solution would be n cubed, just iterate over all triples of positions, but that's too slow. So we need to do it in n squared somehow. And this isn't so bad. So what we're going to do is we're going to iterate over two of the positions. And then the third one, well, now we can just check if that number is in the array or not, right? Like, once we know the first two positions, we know what the third number has to be for those two, three things to add up to x. And so we can just check if we have that or not. There's a little bit of detail about putting the actual positions. So I'll explain that as we actually do it. Make that easier. Okay, so we're going to read all the numbers into the vector. And we are also going to keep a map, or a multi-map actually, of for each value what index is chosen. AI plus 1, because we want to print them out one index. And so we're looking for some triple such that the values add up to x, and we can read an x as well. So we're going to iterate over j and I, and then we're going to check if there's a k, a valid k. So actually, I'm going to iterate over j first, and you'll see why. So the point is that k must be bigger than j. So every time we move on to a new middle element, we're going to delete that element since we want something, an index bigger than it. So this is going to make sure that we don't get any duplicate, that we don't use the same index more than once. Is that the only things left in the map as we're going through, this particular middle element are the things with bigger indexes, so that they'll all be valid. But now we move over I, and I should be less than j, as we said. So if for this to work out, value at ak must be this. So we can check if we actually have one of those. Right, so this is the target value that must have collected in the array if this is a valid joule. So check if we actually still have that value in the map. And if we find it, m.find, if you didn't find it, it returns m.end. So that's what we're checking for, if it actually found it. So it for iterator is basically a pair of the key and the value, right? That's what the iterator of a multi-map is. So in this case, the key is the number, and the value is the index. So we want to have three indexes. Right? I and j are the things we do first over, and arrow second is the value in the map, which is the actual index. So if we find that, we can return, exit the program, because you printed out a valid answer. Otherwise, this pair didn't work, so keep trying. And at the end, if we didn't find anything, they want us to print out impossible. So, and we'll only get to this here, right? Because every time, if we actually find something, we just exit the program. So we only get here if we didn't find anything. So this should be right. So we vector I believe multi-math is part of math. We need utility for better. And this is probably good. And of course, misunderstood and LL. Should be math key value. So numbers. Compiles now. Wonderful. So 1, 3, and 4, that's actually right. That's saying 2 plus 5 plus 1 is 8, which is true. So let's see how that goes. Cool, so that worked. Yeah, so the key idea here is this multi-map, which allows us constant time lookup if we have some value in the array. So right, we have like n squared time to work with. So we brute force over 2 of the indices, and then the last index, use the map. We can find out in constant time if it's in the map or not. And we can store the index in the map too, so that we can actually print out the actual index that we need, not just the value. And this is sort of a nice trick that we're doing here, is that we want k to be bigger than j. So we're just deleting sort of all the smaller values in the map as you go. Right. So like after the j iteration of this loop, m only contains the values like a, j plus 1, to the end. So exactly the indices that are bigger than j. Right, and we just stick everything into the beginning. Right, and so that's why we're looping over the middle value first, is so we can do this erasing properly, and then we can loop over the left value. That's the call.